Okay, so when we're graphing trig graphs, one thing we want to look at is what a periodic function is. Sorry, my microphone's getting twisted. Okay, so here I have a diagram or graph of a function, and this function is or would be considered periodic. And that means that it repeats. Okay, so obviously when I look at this graph, the pattern, I look at the pattern and I could see that the pattern is repeating. So that makes it a periodic graph. So we can determine the period of the graph. And the period can be in any unit. It doesn't have to be in degrees. It can be any unit on the x-axis. Maybe we're measuring time in seconds or minutes. Maybe we're measuring months over seasons. Seasons repeat, so that would be a periodic function. So we can put whatever we want on the x-axis. So when I'm trying to determine the period, you have to start and end in the same spot. It does not matter where you start and end, as long as you start and end in the same position. So for example, I could start at the bottom and I would have to end at the bottom. Okay, so the period looks like this. It's going up, back down, and then it repeats. So that's one cycle, and then it would repeat again. So I could measure, this is -9, and this is -3. So the period is 6. I could do it from top to top. Maybe I'll measure from here to here, right? That's still repeating. I'm up, down, back, and then back to the beginning. So this is at -1. This is at 5, and that's still 6. So it doesn't matter where you start or end. The period will always remain the same. Another thing we can find with a periodic graph is the middle. That's going to be important when we graph trig curves. So if I want to find the middle of the graph, I can take the top and add the bottom and divide by 2. Right? That tells me where the middle of the graph is, and that will be important when we graph sine and cosine. Okay, so this curve has a max of 1 and a minimum value of -3. So I could take the top 1 plus the bottom -3, divide that by 2, and I could find the middle at -1. So that would be the middle of the graph. So I can just sketch that in there. And then that allows us to find the amplitude. So the amplitude is the vertical height of the graph. And that's always measured from the middle. So once I've found the middle, I could actually just read that off the graph if you want. So you could just count. So I could say from -1 up to the top of the graph, that distance is 1, 2, and it should be the same distance to the bottom, right? Because this is the middle. So it's 2 to the top, 2 to the bottom. So I could just count it. If you're a formula person, you like formulas, then you could say that the amplitude is the difference. So it's the maximum minus the minimum divided by 2. So the maximum being 1, the minimum being -3, divided by 2, and that gives me the amplitude of 2. So it's up to you. If you want to use the formula, you can. If you just want to count, you could also do that. So those are some of the properties of a periodic graph. You could figure out the cycle, the period, how often does it repeat. You can find out where the middle of the graph is, and you can find out where what the amplitude is. Okay, so this is also a periodic graph. You can see that the pattern repeats. So if I start here, I go up, down, across, and then I'm back to the beginning. And then it repeats again. I would go up, down, back to the beginning. Okay? So if I was looking at the period of this graph from start to end, it starts at 0, it ends at 2, so the period's 2. If I wanted to find the middle, I would take the top plus the bottom, right, and average it out. So the top is 1, the bottom is 0, so the middle is at a half. Right, so here's my middle, approximately there. And then the amplitude, which is the vertical height, I could find the top minus the bottom, right, the difference. So 1 minus 0 divided by 2 is also a half. Okay, so those are just some general properties of periodic graphs. Okay, so now we want to graph trigonometry graphs. So remember that we did trig, but remember that sine is the opposite side over the hypotenuse. So basically what we're doing to make a trig graph is we are starting at 0 and we are going around a circle back to the beginning. And that would be one cycle. Okay? So going around a circle is 360 degrees, and that's one cycle. So the period of a sine curve is 360 degrees, and then it would repeat, right? Because then I'd be back to the beginning, and then I'd go again. Going counterclockwise is the positive direction. If I went the other way, that's the negative direction. So on my graph, if I go to the right in the positive direction, I would get to 360. If I went left in the negative direction, I would go to minus 360. And so basically what I'm doing, I'm going to make a table of values. So I'm going to pick values for x, and then I'm going to figure out what sine of x is. So I'm going to start at 0, and I'm going to type in my calculator, making sure that my calculator is in the degree mode because we're using degrees, and I'm just going to type in sine of 0 and I would get a value of 0. So that's where my graph is. And then I'm going to pick some values on that circle. So maybe I'll pick 45 degrees, 90, 135, 180. Right? So I'm just picking some values as I go around the circle. So maybe I'll pick 45. So what I'm doing is I'm picking a point that's 45 degrees from the x-axis, and I'm creating a triangle, and I'm measuring the opposite side over the hypotenuse and getting a ratio. And it's okay to use decimals. Okay, you don't have to use fractions. So just type in sine of 45. Just make sure my calculator's in, it's hard to see here, it's in degrees. Okay, there we go. Okay, so sine, if I type in sine 45, I get 0.7, let's just round it to 71. If I type in 90, I get a value of 1. If I type in sine 135, I get 0.71 again. And if I type in 180, I get 0. So I can plot these points. So I'm going to measure 45 degrees, 90, 130. Oh, sorry. Wrong numbers. I'm going to measure. I'm going to cut 360 in half. So this would be 90. This would be 270. So 45 is approximately here. I'm going to go up to 1, down to -1. So sine of 0 is 0. Sine of 45 is approximately 0.75, which is about here. Sine of 90 is 1. Sine of 135 is approximately here. And sine of 180 is back to 0. So the first half of my graph looks like this, and then I will continue that. Pick pick some more numbers. We want to go all the way up to 360. Okay, so now I'll do 225. I'm going every 45 degrees, then I'll do 270, and then I'll do 315, and then I'll do, what are we at, 180, 225, 315, and then I'll do 360. Okay, so at 225, you'll find it's negative 0.71, negative 1, negative 0.71, and then back to 0. So the other half of my graph is at negative 0.7, negative 1, negative 0.7, back to 0. So there's the other part of my curve. So I've gone around the circle once, right? So I picked a point here, picked a point here, picked a point here, here, and here, and then continued around the circle back to the beginning. So those are the values for x I picked. I typed into my calculator to find y, or sine of x, and plotted those points. If I did the left side, if I just did with negative numbers, I would get just a continuation of the graph. So I'm not going to do the table, but you'll find that at negative 90, it's down to negative 1. At negative 180, it would be back to 0. At negative 260 or 270, it'd be up to 1, and then back to 0. So I could draw an arrow at either end because it repeats. So going to the right is going around the circle once in the positive direction. Going to the left is going around the circle once in the negative direction. And then you could just repeat. You could go around the circle again and again and again. So that is a basic sine curve. When we talk about critical points, when we are going to transform it, these are the points that give it its shape. So 0, 0, 91, 180, 0, 270, negative 1. So 0, 0 is the start, 90 and 1 is the maximum point, 180 is back to 0, 270, negative 1 is the minimum point, and then 360 goes back to 0. So this is the minimum point of the graph. This is the maximum point of the graph. So if I'm looking at the properties, we said the period of the graph is 360 because that's one cycle, right? That's once around the circle, and then you repeat to go around again and again and again. The middle of the graph is the top plus the bottom divided by 2. So the maximum point is 1, the minimum point is negative 1. So the middle is always at 0, right, which is the x-axis, right, which is 0. And then the amplitude is the top minus the bottom divided by 2, which is 1. So it has an amplitude of 1. So the vertical stretch is 1. So these are the basic properties of sine without any transformations. So the next part of the guide will be applying transformations to the sine curve and the cosine curve. But you need to remember the basic critical points on the sine curve so that we can use those to transform it. So these are what we call the critical points, and these are what give the graph its basic shape. Right, so you have to remember those. So you need to write those down somewhere so that you can remember them. And this is for sine x. Okay, so cosine x is very similar. We're going around the circle again, but remember, we're just measuring the length of the adjacent side and the hypotenuse, right? So we're going to do the same thing. We're going to go around the circle starting at 0. We're going to pick some points for x. We'll pick the same points. So we are picking an angle, let's say 45 degrees, and now we're measuring the adjacent side and the hypotenuse to find our value for cosine. Okay, so if I do my cosine curve, I'm just going to pick the critical points. You can fill it in if you want. I think in your guide it goes every 30 degrees, so that just gives it more of a shape, right? More of a curved graph, but I'm just going to put the basic critical points. So if I do cosine of 0, I would get a value of 1. If I did cosine of 90, I would get a value of 0. Cosine of 180 is negative 1. Cosine of 270 is 0. And cosine of 360 is 1. Okay, so as I said, in the table there's probably more values, but these are the critical points of cosine. So it has it's very similar to sine, except it starts at a different spot. So 90, 180, 270. And then the same going to the left, going around in the opposite direction. So make sure that you always put values on your x and y axis. You shouldn't leave them blank. So cosine starts at the top of the curve, goes to the middle, down to the bottom, back to the middle, and then back to the top. So it looks just like sine, except it starts at a different spot. So there's my cosine curve. So it is exactly like sine, except it's shifted to the left 90 degrees. So it also has a period of 360, right? That's once around the circle. It also has a middle position at 0. It has the same top and the same bottom, right? The same maximum and minimum value. And it also has the same amplitude. Okay, so same properties, it just starts in a different spot. So the critical points for cosine, and you need to remember these because these are what you're going to start with when you do transformations. The only difference is cosine starts at 0, 1, and then goes back to the middle, down to the bottom, back to the middle, and up to the top. So those are the critical points, or the important points on cosine. Okay, I'm just going to show you tangent. You're not going to have to apply transformations to tan, but it's a little bit of a different looking graph. So the difference in tan, so remember tan is opposite over adjacent. So going around the same circle to 360. So I'm just going to pick some points, right? 0, 45, 90, 135, 180, and then continue around the circle. The problem with cos or tan is that it's the opposite side over the adjacent side, which would be y over x, right? The opposite is y value and the adjacent is x. So when I get to 90, this point here is 0, 1, right? It's a unit circle, so a unit circle has a radius of 1. So that point at the top of the circle is x is 0, y is 1. And at the bottom of the circle at 270, x is 0, y is negative 1. So when I do tan of 90 degrees, you will get error on your calculator, and that's because y is 1 and x is 0. And we can't divide 1 by 0. That's an undefined answer. So at the top of the circle at 90 degrees, you're going to get error. So I'm just going to draw these here. And so because there's an error at 90, it creates a break in the graph. There is no answer at 90. Okay, so it creates a vertical asymptote. So remember with exponential functions, we had a horizontal asymptote where the graph approached the x-axis. In a tan curve, we have a vertical asymptote. And that happens at 90 because there's no answer at 90. That's also going to happen at the bottom of the circle at 270. We'll also get error because we are taking -1 and dividing by 0, right? Y over x. So that would be -1 over 0. So at the bottom of the graph, or at 270, we would also get a break in the graph, an undefined answer, and that creates a vertical asymptote at 270. And then that would happen if we went the other way. If we went in the negative direction, that would happen at -90, and then at -270. So -90 is the bottom of the circle, right? 270 is the same as -90, just in the opposite direction. And so these are the vertical asymptotes that occur at the top of the circle and the bottom of the circle. You're going to draw in a broken line at those points. In between, it's going to have a value of 0. So halfway between these vertical asymptotes, it would be 0. And then it's going to approach the vertical asymptote to the right and approach it to the left. Approach it to the right, approach it to the left. And so tan has kind of a different shape, and it looks like this. So you don't have to apply transformations to tan, but you should know what it looks like. So you would draw your vertical asymptotes in at 90, 270, -90, -270, the top of the circle, the bottom of the circle. Then it hits 0 halfway in between, and then it approaches the asymptotes to the right and the left. So a tan curve has a period of 180 degrees because this vertical asymptote repeats every 180 degrees, right? Every 180 degrees there's a vertical asymptote. So that's the pattern. So the pattern repeats every 180. The middle is still at 0. We're not going to talk about the amplitude because it goes on and on forever, up and down. So there really is no amplitude because it goes to infinity in the positive direction and infinity in the negative direction, so it's not relevant, okay? So you just need to know what tan looks like. You won't have to apply transformations to it. You'll just have to apply transformations to sine and cosine.